In today's tutorial, we will discuss how we can transform this diol with two six-membered annihilated rings into this ketone with a 7 and a 5-membered carbocycle. First idea should of course be, what about a Pinakol-Pinakolon rearrangement? This is a Pinnacle. Pinakolon, well, means there is a ketone, and we have a rearrangement. We need a rearrangement for this transformation. So, how is usually a Pinakol-Pinakolon rearrangement achieved? Just by acidic catalysis. So, let's have a try. We add an acid, we protonate to activate the leaving ability of an OH group, and in this case always the tertiary alcohol will be the better leaving group. In a polar environment, polar solvent, we will have the protonation maybe this is stabilized by a hydrogen bridging bond between the two OH groups, and then this tertiary alcohol, the protonated one, will be the better leaving group, as I said. And we will get to this tertiary carbanium ion. An epoxide formation could take place, but also a deprotonation, for instance here, forming this enol, which will finally rearrange again under acidic catalysis to this ketone. And here we have still two six-membered annihilated rings. The structural rearrangement is missing. Well, what do we need to get to this structure? Obviously, we need the regioisomer as reactive intermediate with an OH group here and the cationic charge at that secondary center. Then a rearrangement could take place and with a simple deprotonation we are here at our final target molecule. So the question is, how can we achieve the selective elimination of this OH group? How can we activate this OH group to be the better leaving group? There is a method. It is the esterification as a sulfonic acid ester. And standard reagent for this purpose is using paratoluene sulfonic acid chloride, TOSCl, in pyridine. The selectivity is simply achieved by the fact that the secondary alcohol is sterically less hindered compared to the tertiary alcohol, and highly selectively we will achieve the formation of this partolene sulfonic acid ester. To activate this as a leaving group, we could either choose a polar solvent and elevated temperature, or we could apply a Lewis acid as an additional activator. And then the transformation and rearrangement will proceed smoothly. Thanks for listening.